Hi Year 13s. In this video we're introducing something called de Moivre's theorem, or de Moivre, depending on how you pronounce it. I'm probably always going to call it de Moivre's theorem. I'm not exactly sure if I'm saying that right. But there's an explanation here, but if you think about it, it's actually just an extension of the rules that we looked at in the last video. So in the last video we looked at the multiplying rules, and we found that when we multiply, we just multiply the moduli together. And with de Moivre's theorem, it's simply saying if you've got a complex number to a power, then you just take the power of the modulus and multiply the argument by the number of that power. And that's for any number that's an integer. Okay, so looking at this first example here, applying that formula straight out, this is going to be 2 to the power of 5 cis 45 times 5. And so 2 to the power of 5, probably you just work it out in your calculator, but 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and 45 times 5, that's going to be 200 plus 25, so 225. Now, just thinking about this on a Argand diagram, 225, well, that's 90, that's 180, and that's 270. So 225 is going to be kind of out here-ish, 225. And the modulus of 32 is that length there. Now, there is another way to write this, because you can write the angle as negative, and so you would just go 360 minus 225, and whatever that answer, make it negative, so that's going to be 135, so we could write that as negative 135. So another answer which would be the same or equivalent is 32 cis negative 135, and both those answers are equivalent. Doesn't actually matter which one you use, so long as you use one of them. I personally prefer positive angles, but that's totally a personal preference. There's no mathematical reason for that. Okay, we'll go to the second example. So here we're using de Moivre's theorem to expand this expression, and so what we're going to have to do is, first of all, make the complex number 3 plus I. We're going to have to put that into into polar form. So first of all, r is going to be equal to the square root of 3 squared plus 1 squared, so that's going to be root 10, or we could write that, no, root 10 is as good as we'll get with that. Okay, and then in terms of our argument, so our argument theta is going to be equal to tan inverse of the imaginary part over the real part, and so that's going to be shift tan inverse 1 over 3, so that's 18.43 degrees. Oh, I'll just check that I'm still in degrees, so 18.43 degrees. So the angle is 18.43 degrees. Okay, and so in polar form we could be writing this as root 10 cis 18.43. And so in this question it's to the power of 6, and so what we're really doing is finding z to the power of 6, and so that's going to be root 10 to the power of 6 times cis 18.43 to the power of 6. So root 10 to the power of 6, well, that's just 10 to the power of 3, so that's going to be 1000. So z6 is going to be 1000, and that shouldn't be to the power of 6 there, that should be times 6, and that will do in our calculator. So times 6 equals, so 110.61, 110.61 degrees. Now if we just look at the question again, it's asked us to expand this, so really we ought to put it back into rectangular form, and so if we just draw a diagram to help ourselves understand that. So here's our diagram. 110 degrees is going to be sort of out here-ish, so 110 degrees, and this modulus here is 1000 units, and so we want to work out the real and imaginary part. So the real part there is going to be negative, so we want to work out this distance. So if that's 110, then this distance here is going to be approximately 70 degrees. We can get the exact number in our calculator, and if we know that's 1000, then this is the adjacent that we're looking for. So we can say that cos 70-ish is going to equal a over 1000, and so our real part is going to be 1000 cos 70. So what I'll do here is I'll just go 180 minus my answer, so I've got an exact value up on my calculator, and then I'll put that in my memory, so we'll call that there. Okay, and we're looking at 1000 times cos of alpha A, and so we get 352 exactly. So 352. So that means that our real part of z to the 6 is going to be negative 352. Why is it negative? Because it's on the negative side of our arcgan diagram. Okay, now we're going to do the imaginary part, which is this part here, and so that's going to be using sine. So we can say that sine 70 is going to be, we'll just call that what's opposite, so let's call it O. O over 1000, and so O is going to be 1000 times sine 70, and we'll use the exact value from our calculator. So 1000 sine alpha A, and unsurprisingly an exact value again of 936. So the opposite side equals 936, and so we can write Z6 as plus 936i. Now just you know, as an exercise in interest, if you're really keen, you could actually expand this by writing out 3 plus I, 3 plus I, and so on 6 times, and then expand that in rectangular form. Now I have seen students attempt to do that in the exam, and holy moly, it takes up a lot of space, and it takes so long, and this sort of question is probably like achieved or merit. It's not worth spending a lot of time on, whereas when you're whipping it out like this real quick, you don't have any worries. So just make sure that you use polar form to do that, because you save yourself a heck of a lot of time, and if somebody wanted to do that, I'd love to see what it looked like, but I estimate it would probably take you about half an hour. Okay, but that'll set you up for doing these exercises here, and keep the questions coming in, people. But I think this is actually our second to last video, so we nearly finished up with the content side of algebra.